Welcome grade 12s to today's lesson, and what we're going to be looking at today is we are going to do Newton's law of motion. Okay, and this is grade 11 revision. I know I can hear the groaning because we all hated it in the grade 11, but unfortunately it is examinable. Okay, so you've got to know it and revise it from last year. What you need to do is just go through, well, we're going to go through a checklist quickly of what you need to know from last year. That's important. Now, the first thing we need to look at is the fact that you need to be able to state Newton's first, second, and third law of motion, okay, as well as Newton's law of universal gravitation. Grade 12s, I know we don't like learning definitions. Learn them like a parrot, make a list of them somewhere, and just learn them. Get them from your textbooks, okay? Easy, 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 easy marks. You are going to get at least one of those four, okay? So make sure you know them. Very, very important. Secondly, make sure you know the difference between a free body diagram and a force diagram, okay? Very, very important. Why? Because if you get asked in your exam to draw a free body diagram and you draw a force diagram, you get naught, okay? They don't even look at what your labels are. They don't look if they go in the right direction. They don't care. It's wrong. If you draw a free body diagram when you're asked to draw a force diagram, you also get naught because you haven't obeyed the instruction, okay? You haven't answered the question. So make sure you know the difference, okay? Make sure you know how to label them, okay? Very, very, very important. Also, free body diagrams in particular are very useful when answering questions, even if you're not asked to draw one, because they help you understand the problem, okay? So they're very important. Thirdly, you must know the difference between kinetic and static friction. I know I can hear the groans because we hated that in grade 11, all right? But remember, there's a calculation based on it that involves the normal force and your coefficient of friction, okay? It's exactly what it sounds like. Kinetic means moving friction. Static is friction that is static, doesn't move. Remember, kinetic friction is the one that is constant, okay? Once we have an object moving, the friction won't change, where static friction will actually increase to a maximum before the object starts to move. All right, very, very important. Also, you need to remember how to calculate friction, okay, using the fact that you are given the equation on your information sheet, which is great, okay? So make sure you know how to use it. You must know how to calculate resultant force, okay? And on that note, you need to be able to use the equations F net equals ma. Remember, that is from Newton's second law, and of course, F equals g m1 m2 over r squared, which is universal gravitation, okay? And remember, with universal gravitation, big G is your constant, okay? Big G is your constant, will be given to you on your information sheet. You don't need to learn what that constant is, okay? So don't stress about learning constants. All will be given to you. It's about being able to apply them, okay? So let's dive straight into the first question that we have. And the first question that we have is taken from the grade 11 Department of Basic Education exemplar from 2013. Now, I'm sure some of you are going, but Tracy, why are we doing grade 11 work? Because this is grade 11 work, okay? And you are going to be asked it like you did in grade 11. Maybe add a little bit of grade 12 work to it, add a little bit of momentum maybe, a little bit of work, energy, and power, but it's all the same thing, okay? So this is where we're going to start. So in the diagram below, we have a 1 kilogram mass on a rough horizontal surface. As soon as you see the word rough, that means there is friction, okay? With friction being involved, that might be kinetic or static. We have to see what happens with the rest of the question. It's joined to a 2 kilogram mass by a light, inextensible string. What that means is that the string joining the 1 kilogram and the 2 kilogram can't stretch, first of all, and its mass can be ignored. Remember, mass does play a part in Newton's second law, but we're saying ignore it, okay? It is also running over a frictionless pulley. Now, that's important because if there's friction in the pulley, which is my circle over here, that will affect the way it moves. And they're not going to put friction in the pulley. That's just making it far too complicated. The coefficient of kinetic friction between the 1 kilogram and the kilogram mass on the surface is 0.13. So what they're telling you is that 1 kilogram mass experiences kinetic friction. It's going to be moving. And the coefficient, remember, which is mu k, is 0.13. So everything that I've done on my screen here, grade 12s, that is exactly what I would expect, or I suggest that you do when you get a question like this in your exam, or any question. You all know, hopefully, about the concept of active listening. When you really listen to someone in your head, you're not going, and you're thinking, okay, this is what I'm going to answer, this is what I'm going to say, but meanwhile, you're not actually hearing them, but you're actually listening, you're taking in what they're saying. This is what I like to call active reading, because sometimes it's just words on a page, so we read it, but actually nothing's going in. But by having a pen or a pencil or highlighter in your hand, underlining stuff, writing stuff down, things that you need to remember about the question, it really does make it easier for you later on, okay? So I've got a whole bunch of stuff written there. Let's go on to the questions and see what they say to us, okay? Also, I know, because I've said to you right from the start, that this is a Newton's second law question because I have two objects joined together, okay? That's a good way of knowing that it's going to be a Newton's second law question. And then, of course, the first thing they ask you to do is state Newton's second law of motion in words. Now, they're saying state it in words because what they're saying to you is that you can't say F net equals ma. Okay, you can't give me an equation. It has to be in words. Now, what are we looking for? Now, grade 12s, I have said to you learn it like a parent. There are slightly different ways of stating it, but they're looking for certain things that are the same regardless, okay? And I'm really going to do this in a very summarized form, so hopefully you can take this down as we go along, okay? Because we're not going to write all the words out. First of all, when you have a resultant force, okay, not an unbalanced force, it has to be a resultant force acting on an object, okay? So we have a resultant force on an object. The object, okay, accelerates, so it accelerates, I'm just going to put it like that, in the direction, this is the first part, so it's the direction of the resultant force, or F net. First part, okay, we have to talk about direction. Why do I have to talk about direction? Because acceleration, resultant force, or net force are vectors. Okay, so it accelerates in the direction of the resultant force. Now be careful here, please, grade 12s. Is often from here I see now, because F net equals ma, I see that F net is now inversely proportional to mass and directly proportional to this. F net is not inversely to anything as such, okay? It is the acceleration, okay? The acceleration of your object is dependent on the resultant force, and it's dependent on the mass. So we have to write it in terms of acceleration. Because now I've talked about the direction of the acceleration. So now what we say is that that acceleration, okay, is, now watch, directly proportional, okay, directly proportional to the resultant force. In other words, the bigger the force, the bigger the acceleration, okay? And, now watch, inversely proportional to the mass, okay? It's directly proportional to the resultant force, inversely proportional to mass. In other words, the bigger the net force, the greater the acceleration, the bigger the mass, the smaller the acceleration, okay? 2 marks for a question like this, and pretty much they're all or nothing marks. You get it or you don't, okay? Seems like a lot of writing. Yes, it is, but remember you have time in your exam. So, had to state Newton's second law. Very good clue that I'm probably going to need to use it later on. So, next part of the question says to us, calculate the magnitude of, no direction necessary. Okay, great, we like those. The frictional force acting on the 1 kilogram mass. Now remember, earlier on, we said that mu k is 0.13. On your information sheet, you have an equation that says this. Kinetic friction equals mu k n, okay? If kinetic friction is what I'm looking for, mu k is 0.13, so the issue here is what is n? Now remember, n is your normal force, And if we look at my diagram, the normal force is the force that acts upwards. We like this question because the normal force is nice and easy to calculate. It's simply an object sitting nice and flat, no forces at angles. The force is horizontal. Nothing's affecting the normal force except the force of gravity. So your normal force is equal to the weight of the object, okay? So my normal force in this case is equal to my weight. And remember, to calculate weight, we're going to do mass times gravity, which is 9,8. That means this is a straight substitution. So we're going to have 0,13. My normal force is the 1 times 9,8, and that gives me 1,27 newtons, okay? What do I do with this information? Well, actually, I'm going to go back here, and I'm going to write it in. My kinetic friction, which goes in the opposite direction, is 1,27 newtons. Now, I've done it in different colors because it makes it easier. By this stage, your diagram looks like a dog's breakfast, but that's okay. I'm probably going to need this information, all right? Now they say to you, wow, calculate the acceleration of the 1 kilogram mass. So we go, all right, what do I know? I know the friction on the 1 kilogram mass, and I know that it's being pulled to the right by the 2 kilogram mass, okay? Please be careful here. Some of you have probably been told that you can add the two masses together and use the mass as one, but you can't in this particular question, simply because the 1 kilogram mass is moving horizontal, the 2 kilogram mass is moving vertically. You have to consider them as two separate objects, okay? So what we're going to do is we're going to draw a free body diagram for the 1 kilogram and for the 2 kilogram, okay? Now, the normal force and the force of gravity on the 1 kilogram mass, irrelevant, doesn't matter. Vertical makes no difference to its horizontal motion. On the 2 kilogram mass, we have the tension in the rope pulling it up, and we have its gravity pulling down. So I'm going to take the 1 kilogram mass on its own, and I'm going to take the 2 kilogram mass on its own. Okay, so first step I'm going to do is I'm going to draw two free body diagrams. So for the 1 kilogram mass, okay, it simply has its kinetic friction moving backwards and tension moving to the right. Now, some of you might have been told you can use capital T. That's fine. I just prefer to use FT because it reminds me that I'm working with a force, okay? For the 2 kilogram, what we have is we have the tension moving up and we have gravity moving down. Now, grade 12s, there are no marks for these two little diagrams. This is for me, okay? This is for me to remember what's actually taking part in this reaction, okay? So what we're going to do is from here, we now set up two equations. We're now going to apply Newton's second law. So F net equals ma. So now we look at this and we go, which direction is the 1 kilogram mass moving in? Well, the 1 kilogram mass is on the table and it's actually moving to the right towards the 2 kilogram. So Ft is bigger than Fk, okay? Now, what if you got the kinetic friction incorrect in 1.2.1? It's okay. You're obviously losing your marks there, but if you take that value for friction that you found and you substitute it correctly, you get the marks, okay? So don't stress about it. Don't stop because you're not sure about one of them. Keep going. Do what you can, grade 12s. So my tension minus the 1,27 equals 1 times A, okay? This is equation number 1. I'm just going to make it a bit easier for you to see what I'm doing. So I'm going to do equation number 2. I'm going to do this here. Normally I would actually write them next to it, but I write too big on these screens. So this is for the 2 kilogram. Okay, the 2 kilogram is moving down, which means its weight is bigger than the tension up. And for the 2 kilogram, its weight will be 2 times 9,8. Please don't use 10. All right, do not use 10. They will not accept it as the force of gravity. Okay, well, acceleration due to gravity because it's not 10. Okay, it hasn't been, and my page, there we go, my page has decided it will extend for me. All right, so this gives me 19,6 minus ft equals 2. Now, at this point, there is now a couple of ways for you to solve for A, because that's what we want. We want the acceleration. Grade 12s, there's no one way that is the correct way and the only accepted way. Please understand that. I prefer to do the way I'm going to do now because this is a check. In fact, at my own school, myself and a colleague of mine, we teach this differently. She doesn't like to do it this way. She does it another way. Nothing wrong with that, okay? This is just the way I prefer it because it is a check. And that's what I like, is if we can put checks and balances in place, then it makes life a little bit easier. Okay, so what we're going to do is I'm going to take the first equation we set up and I'm going to add it to the second equation. So the first equation was ft minus the 1,27 equals 1a, 19,6 minus ft equals 2a. Now we're going to add them together. The reason why I do this is if I've set up the equations correctly, ft cancels because I have ft minus ft. As soon as they cancel, I know my equations are set up correctly. All right, and that means I'm now going to go 19,6 minus 1,27, okay, and of course we would do it on our calculators and we get 18,33, which is equal to 3a. That means a equals 6,11 meters per second squared. What you need to be doing at this point, grade 12s, is check your answer. All right, often I see this and then I get answers that are bigger than 9,8. Not possible. Okay, not with this sort of situation. The object on the desk cannot accelerate more than friction, more than gravity, especially if there's friction involved. Okay, please, please, please be careful. What we could do from this junction, if we really wanted to, is ask you to calculate tension. Easy enough, substitute it into one of the two equations you've set up above. Okay, so let's go see what they asked us next. Now they said to you, okay, so the rough horizontal surface is now replaced with a smooth, frictionless surface. The 2 kilogram mass is released and strikes the ground before the 1 kilogram mass reaches the end of the horizontal surface. Will the 1 kilogram mass move at a lower, a higher, or a zero acceleration? Well, so this becomes a little bit of where they're actually asking the question. Okay, so the rough is now replaced with a smooth surface. That's great. That means the only force acting on it is Ft, and the 2 kilogram mass is released, strikes the ground before the 1 kilogram mass reaches the end of the horizontal surface. So what we need to recognize is this 2 kilogram mass, the only force going back on it, okay, is the 1 kilogram, okay, which is Ft. Ft, the only force acting on the 1 kilogram mass is the 2 kilogram, okay, and let's just see what happens. So we've got to think about this, okay. Now I want to go through what we've done. So F net equals ma. So for the 1 kilogram, it's simply 1a. For the 2 kilogram, we've still got the 19,6 minus Ft equals 3a. So Ft equals, oh no, what am I doing? And this is how you work it out, so not Ft, it's not what I wanted. If I add the two together, okay, that means I get 19,6 equal to, not 3a, that's 2a. All right, sorry, let's do that. What happens when you think too quickly? So we get 3a. A is obviously bigger. Can you see that? Because now they ask you, will the 1 kilogram mass move at a lower, higher, or zero acceleration? High acceleration. Okay? higher acceleration. Guys, what I've done here, this little piece here, that gets done on your question paper. Okay? That gets done on your question paper. Please understand that. Now, it's released the grain, strikes the ground before the 1 kilogram mass reaches the end of the horizontal surface. So what they're saying to you is, it hits the ground, but the 1 kilogram mass won't go over the edge of the table. That's all it's telling you. Briefly explain your answer by referring to Newton's laws of motion. Well, the first thing is we have to say higher, so that gives you your first part. Secondly, briefly explain by using Newton's laws of motion. Well, this is Newton's second law. Now, what we've done, okay, is the resultant force, F net, on the 1 kilogram mass is bigger. Okay? There's no friction anymore. Okay? Therefore, if A is directly proportional to F net, then A increases as F net increases. How do we know this? This is Newton's second law. Okay? Newton's second law. Okay? If they had asked, what happens to the acceleration after the 2 kilogram mass hits the ground? Okay? Then the 1 kilogram mass will actually keep moving at a constant velocity. So acceleration will become 0. So the question's not really well worded, okay? Because if it is asked what happens as it's moving, it's going to increase. Once the 2 kilogram mass hits the ground, there's no more force pulling the 1 kilogram. Net force is going to be 0. Okay? If net force is 0, Newton's first law says to us that an object will remain at rest or move a constant velocity in a straight line unless acted upon by a resultant force. So if we take away that resultant force, which is the 2 kilogram mass pulling it down, its acceleration becomes 0. So they weren't 100% clear as to what part of the motion they're referring to. Always refer to the one that, to me, or to yourself, seems most logical, where it first begins. Okay, so grade 12s. With that, we're going to take a short break, and then we will carry on with another Newton's laws question. Welcome back, grade 12s. Let's jump right into another question, and don't groan when you see this question, because we know how much you hate these ones, but it's okay. So, question 2, also adapted from the Department of Basic Education exemplar from the grade 11s in 2013, sorry. All right, so a skier of mass 60 kilograms skis from rest. So let's use a different color because we can. Ooh, bad color. Don't think you can see that. Anyway, 60 kilograms. Ooh, that's even worse. So let's do color you can use, shall I, grade 12s? There we go. 60 kilogram skier. All right, so he's 60 kilograms. All right. Skis from rest, which means VI equals 0, down a slope. Okay, an incline of 15 degrees. Here it is. The length on the incline is 75 meters, already written. He reaches the end of the incline at a velocity of 15. And then they tell you, oh, look, constant frictional force acts on the skier on the way down. If there's a frictional force and he's moving, that means it is kinetic friction. I already can see, grade 12, some of you go, this looks too much like work, energy, and power. Yes, it does. Don't freak out till you read the question. Okay, so, not too bad. It looks okay. Let's see what the first question says to us. Write down an expression that means it's an equation for the magnitude size of the normal force acting on the skier, and then calculate its magnitude. So they're saying to you, okay, well, work out what the normal force is. So here life gets very interesting. So we've got to remember, and I'm going to do this in a different color, that the normal force acts up on the man. okay, on the boy. I'm going to take out the 60 kilograms because I want to make it a bit easier in a second. Remember, normal force acts up, and the normal force is always perpendicular to your slope. Gravity acts down, okay? Now, the normal force isn't, in this case, is not the same as the one we did in the last question, because in the last question, the normal force was equal to the weight of the object because it wasn't at an angle, so it was easy. Now we've got at an angle, which means we've got to remember that we're going to have to use components, okay? And what we recognize here is that actually, and look here, it's already a dotted line for me. I love it. Okay, and I'm doing it as a dotted line for you to see that we have my FG perpendicular and FG parallel, okay? Hopefully you've remembered how to work these out, and you also remember that this angle here is 15 degrees. Your normal force is equal to your perpendicular weight component, okay? So normally we would say the normal force is equal to weight. It can't be equal to weight. It's got to be equal to your perpendicular component. So by an expression, what they want you to say is that your normal force, if you write it as Fn, that's fine, is equal to the perpendicular component of your weight. That is not the expression. The expression means write a mathematical equation. So now we go. All right. According to where my angle is, and the angle in the middle of that triangle is always the angle of the slope, my perpendicular component is adjacent to the angle. I'm using the hypotenuse. The hypotenuse is Fg. My adjacent component means I've got to use cos. Okay, guys, if you're not so hot on your trigonometry, we all have those moments, go and learn these equations. Okay, very, very important. And remember that Fg is actually mg. So that means my expression is this. Mass times acceleration due to gravity times cos theta. You have to write the expression down. Okay, now calculate n. Well, m was, they told you, was 60. G is 9,8. Angle is 15 degrees. We plug that into our calculator. And 567,96 newtons. Okay? It's fine. It is less than 60 times 9,8, but we expect it to be less because it's at an angle. Okay? We're happy with that. Next question. Draw a labeled free body diagram showing all the forces acting on the skier as he skis down the slope. Grade 12s. What I have done on my diagram over here, this is not a free body diagram. Okay? Mainly because I put components on the same diagram as FG. Please, you may not do that. Okay? You cannot put components onto the same diagram. Don't do it. If I took the components away, so I ignore the purple or pink, I think it's more pink, okay, and I just look at what I've done in green, I have the start of a free body diagram. What I am missing is friction, okay? And they said to me that friction is kinetic friction. Oh, sorry, let me just write that the way it should be written. Okay, it's one way to write it. Let's just keep it consistent. It's kinetic friction, okay? I have the starts of a free body diagram, okay? So your free body diagram must follow the shape of the original diagram. Don't make it horizontal or vertical. Don't change your incline. It was at 15 degrees. It must stay at 15 degrees, okay? Now, your free body diagram, we're going to make it a nice, neat one, okay? Gravity acts vertically down. Your normal force acts an angle, and your friction must be at 90 degrees to your normal force. Now, these aren't all nicely put together, so let's just make sure they all come from the same spot, okay? Because if they don't come from the same spot, then they're not a free body diagram. And the thing with a free body diagram is the object is a dot, okay? Still not done. Question said draw a labeled free body diagram. Now, the labels, you may write it in, say, let's just go with the friction. You can write FK and then do a key to the side. You're welcome to do that. I think what's a better idea, though, is to actually go and write it in. This is friction. Label your diagram, okay? This is weight. And this is the normal, okay? Remember, the normal can also be labeled as the force of the surface on the object. Weight can be the force of the earth on the object, the force of the gravity on the object. Friction is frictional force. You can't actually label as anything else, okay? Must be labeled. 3 marks, guys. If you draw a force diagram, so it doesn't look like this, okay, no marks. If you don't label it, no marks. If it's not at the right angles, no marks, okay? If you add in extra stuff, you start to lose marks. You can't get full marks if it's not 100% correct. So don't think that if I add in more stuff, I'm going to get more marks, because it doesn't work like that, okay? That's all nice. You're wondering, okay, where's the hard part, Tracy? Question 2.3. So, now they say to you, calculate the average frictional force acting on the skier during his motion down the incline. First of all, let's just remind ourselves that, that your normal was 567,96 newtons, okay? They want the average frictional force acting on the object. First thing you need to say to yourself, can I use friction equals coefficient of friction times times normal? Can I use this? Answer, no. Don't know mu k, okay? You cannot use tan theta and use the 15 degrees to calculate the mu because it's not static friction. So we can't do that either, okay? But we now look at this and we go, well, I know that he has a force pulling him down, and the force pulling him this way is actually the parallel force of friction, and if to get the perpendicular force I used cos, I need to use sine for this one, okay? Then we're going to say, okay, well, if I could work, I can work out FG parallel, that's easy. If I knew that, maybe I could use F net equals MA, because I know that FG minus FK would give me MA. I know M, brilliant. Ooh, A. Okay, so now we look at this and we go, okay, I need to work out A, but what I do know is that VI is 0. I do know that VF is 15. Ooh, and I know a distance. Now, I'm pretty sure someone is screaming at the TV right now and going, but Tracy, he's moving down a slope. Why isn't A 9,8? Because he's experiencing friction. If there was no friction, very possibly A would be 9,8. Do not assume it. Okay, do not assume it. So, let's see what I know. VF equals 15. VI equals 0. From what I wrote above, I know I need A. I don't have anything to do with time, but I know that he goes 75 meters. So we're now looking at this and going, hang on, wait, Tracy. They look like stuff I'd use in equations of motion. Absolutely. But we're doing Newton's second law. I know. But there's nothing in your curriculum that says that you can't do equations of motion on a slope. Okay, remember, you have done equations of motion. You did vertical projectile motion. We absolutely can ask you this. Okay, this is not an equation for you. We want A. Best equation, remember, you have 4. Use the one that has most of this in, and that happens to be BF squared equals VI squared plus 2A delta X. VF is 15. VI is 0. This is 75. So 15 squared is 225. This is 150a. We divide by 150 on both sides, and we get 1,5 meters per second squared. That's down the slope. So now I've got A. Yay, have A. Need to work out FG. Now I can use Newton's second law. So we go, fine. I'm going to do this. F net equals MA. Okay. I like to do everything in one equation if I can. I could not have done A inside this equation, but if I can do all the other stuff in the equation, absolutely, let's go that way, because it also solves the rounding problem. Okay, do I keep the answer in my calculator? Do I round it off? Just do it all in one equation. It just makes it much, much easier. Okay, now we said F net would be FG parallel minus my friction. Okay. Well, actually, if I'm going to be technically correct, I can't actually say minus my friction. I have to say plus my friction. All right, remember, this is down the slope, so I'm saying anything down the slope is positive. Okay, be careful with minusing because you're going to get a whole thing with direction. And remember, they're now saying calculate the average frictional force. They didn't say magnitude. That means I have to give direction, okay? FG, we said earlier that, remember, we put it on the diagram over here. It's FG sine theta. FG sine theta means it's mg sine theta. Okay, plus my friction equals MA. Guys, all of this part, that's your science, okay? That's the science. The rest of this is straight substitution. Straight substitution. The mass was 60. Gravity was 9,8. The angle of the slope is 15 degrees. I want friction. Mass is 60, and I've just worked out that, should I write it so you could read it? It always makes it a bit easier. I do understand that. Is 1,5. From here, straight calculator work, okay? So what you need to recognize is that I would end up doing this. I'm just going to show you, and I'm going to minus whatever that gives me. Okay. And I end up with minus 62,19. What does that minus mean? It means that it's in the opposite direction to the motion. It's up the slope. Does that make sense? Absolutely. Okay, because if friction didn't go up the slope, it wouldn't be resisting the motion of the person, okay, of the skier, who actually in the diagram looks more like he's ice skating, but that's neither here nor there. Okay, so if he's moving down, friction moves up. Friction is always in the opposite direction, okay? Must give me a positive answer, come pen, positive answer, direction in words. Okay, very, very, very important. So hopefully what you've learned from this question in grade 12 is you actually need to go back and revise equations of motion again as well. Okay, they absolutely can combine them. And of course, if we were feeling really, really, really mean, I could now turn this into a work energy and power question. But we're not going to today because we're just focusing on Newton's laws. Okay, so grade 12s, once again, it is now time for a little break. Go get some water, have a bit of a drink, and when we get back, we're going to tackle Newton's law of universal gravitation. So we'll see you in a little while. Welcome back, grade 12s. All right, so we've done Newton's second law. We've done quite a bit on it. We've touched a little bit on Newton's first law. We now need to head into Newton's law of universal gravitation. I really like Newton's law of universal gravitation. It's one of those ones where actually there's only so many things they can ask you, so it makes life easier. Let's dive straight in. So they tell you, satellite A with a mass of 615 kilograms is in orbit around the Earth. We don't care what satellite A is. It can be debris. It could be an actual satellite. That's how you actually get in this transmission, or you know, how cell phones, or doesn't actually matter. Okay, so could be the moon, though it's 615 kilograms, it's not the moon. First thing they ask you to do is to state Newton's law of universal gravitation in words. Okay, so in words means may not use the equation. The equation, though, is that force G m1 m2 over r squared. the equation helps us, okay? But first thing we have to remember, this is Newton's law of universal gravitation. Gravity is an attractive force. It cannot ever be repulsion. So despite what you might think, you actually have an attraction for your workbook. All right, you have an attraction towards your science book, okay? Because you're an object and your book is an object, okay? I know it doesn't always work that way and you'd rather just throw it out the window at times, but hey, that's all right. So, state Newton's law of universal gravitation. So, first of all, any, not Emmy, should I write it so you can read it? So it's actually in English. Any two objects attract each other. Okay, and this is any two objects, not object, in the universe. Okay. Guys, it's universal gravitation. As far as we know, that no matter where you go in this universe, this law will stand true. Okay, and it has been proven over and over again. Obviously, we can't prove it anywhere in the universe because we can't get there yet. But hey, we'll get there one day. We're almost at Mars, so why not? Okay, first part. This force, now watch, is directly proportional to, be careful here, okay, the product. Product means multiplication of the masses. That's the first part of the equation. M1 times M2. And inversely proportional. Now watch, this is where we get it wrong. To the square, because it's r square, of the distance between their centers. Guys, it's from the center of gravity. It's from the middle of the object, okay? So when we're talking about the gravitational force of attraction with the Earth, we actually take it from the middle of the Earth. So we have to consider the radius of the Earth. With big objects, that radius is really, 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 really important. With little objects, and you and I would be considered little objects, that radius isn't as important, okay? Because our center of gravity sits in the middle of us, okay? And actually, compared to the center of gravity, the Earth, my radius, very little, okay? Or if I had to consider the force of attraction I have for my wonderful smart pen, the center is millimeters, okay? We pretty much don't really worry too much about it, but with the Earth and big objects, that center is really, really, really important. Okay, so let's go into the equations, because I know this is where life gets a little interesting. If the Earth exerts a force of 5,000 newtons on satellite A to keep it in orbit, calculate the height in kilometers of the satellite above the surface of the Earth. So pretty much, if we put this as a diagram, okay, here's the Earth, here's the satellite. That's A, okay. The Earth has a radius, okay, of something, and what I'm actually looking for is, what is this height, okay? So now we got to look at this and we've got to go, okay, wow, I think I left out some very important information on this question, but we'll get back to that in a second. All right, I left a lot of information actually on this, but on your information sheet that you will be given the mass of the Earth, and you will be given the approximate radius of the Earth, okay? I didn't put it into this question, I've just realized that, but it's on your information sheet, grade 12s. You do not need to learn what the mass of the Earth is and the radius of the Earth. I can't tell you that, okay? So please, grade 12s, don't get all freaked out about this. If you look at this and you go, oh, I don't know what's going on, it's okay. It's okay. Deep breaths. let's call this radius of the Earth. That's a much better way to put this, and let's just make this R. So, force of attraction is 5,000. The mass of the Earth will be on the information sheet. The radius of the Earth will also be on the information sheet. So, F equals G m1 m2 over r squared. Now, F is 5,000. They told you that, okay? G is on your information sheet because it is a gravitational acceleration constant. It's the universal gravitational constant, and it is 6,67 times 10 to the minus 11. The mass of the Earth, and I'm going to run out of space on this one, so just go with me. I'm just going to write a little bit smaller, is 5,98 times 10 to the 24, okay, and the radius, well, the mass of the satellite is not some random number that I seem to be writing down, is 615, and I'm doing r squared. Now, right now, I'm pretty sure some of you are going, but Tracy, wait. Where's the radius of the Earth come in? Just now, okay? Because what I'm actually calculating here is the distance from the center of the Earth to the satellite, okay? I can't do this in one equation like I said in the previous section because it's going to become difficult with the r squared, okay? So let's just leave that for now. So that gives me r squared, and once again, I did not leave myself enough space. So we're going to have 6,67 times 10 to the minus 11, 5,98 times 10 to the 24, 615 divided by 5,000. Oh, excuse me. All right. Now, r squared turns out to be 4,91 times 10 to the 13. We are not done, okay? So what we've got here is there's my Earth, there's my satellite again. I'm just going to remind you. So there's A. We've just worked out that r squared is 491 times 10 to the 13. First of all, it's r squared, not r. So that's my first issue. So r is actually 7,00 times 10 to the 6. If you want to keep this with all the numbers involved and not in scientific notation, you're welcome to do that. I don't suggest it, though it's going to make your life difficult. We're still not finished because this r is the distance from here to here. That's not what I asked. I asked for what is the height above the Earth, okay? What is the height above the Earth? So what that means is this r, that distance that we've worked out, is actually the distance with the radius of the Earth plus the height above the Earth, okay? Plus the height above the Earth. So RH, which is the height above the Earth, let's just actually write it out nicely so we don't get too confused with what we're writing, okay? So to get the height, it's going to be equal to the total distance, which is r, minus the radius of the Earth, okay? So once again, you're now going, oh, but Joyce, I don't know the radius of the Earth. I know. It's on your information sheet. So that means I'm going to go 7,00 times 10 to the 6 minus 6,38 times 10 to the 6. Grade 12s, I don't know the radius of the Earth at the top of my head, okay? I have to look it up, which means it's on your information sheet. That gives me 6,20 times 10 to the 5. But that's in meters. The question said, what is the height above the Earth in kilometers? Okay? So, we look at this and we go, okay, 620 times 10 to the 5 is actually 620,000 meters. I want to get it to kilometers, so now we remind ourselves and we go, hang on, wait. There are 1,000 meters in a kilometer, so I'm going to divide by 1,000, 620 kilometers. Final answer. Okay, 620 kilometers. Guys, do not leave your answer in meters. I know you want to because that is what our usual unit is, but the question very specifically said, what is the distance above the Earth in kilometers? Okay, yay, not so bad. Now, next part. Now it says, another satellite with a mass double of A orbits at a distance twice that of satellite A from the center of the Earth. Write down the magnitude of force of attraction of the Earth on this satellite. Only worth 2 marks. Straight away, this is telling you that I mustn't now go and put everything back into the equation and work it out, okay? As soon as you start seeing the words double, twice, quarter, half, whatever, this is what we call a ratio problem, okay? This is a ratio problem. So I'm going to show you a method to work this out. Everyone does this differently again, but I want to show you a way that hopefully will make it a little bit easier for you. And what I like to do with a question like this is now we need to do a comparison, okay? So I'm going to compare an equation that I know for A with an equation I find for B, okay? So this is what I know. The force of A would be equal to G. Now, the 1 and the 2 in the equation that we used is simply a placeholder, like an X or a Y. So this is what I'm going to do. Mass of the Earth, mass of A, over R squared. This happens to be 5,000. How do I know that? It was given to me at the beginning of the question, okay? This is my starting point. What I want to do is I want to work out an equation with B where I now go, how can I compare the information I know about B with the information I know about A? So watch here. This is what we're going to do. Oh, no, look, it's a clock. All right. Here we go. Force of B. I don't think you can see that. Okay, let's do this. Do it in green. There we go. Force of B. Force of B means it's going to be G, mass of the Earth, mass of B, radius of B squared. Okay? So now, what I know from the above question is that it has twice the mass of A and twice the distance. So, that means if I go G, M, instead of MB, because they said to me that actually it's twice the mass of A, I'm going to put twice the mass of A in there. Okay? They told me that RB is twice the original radius. So that's twice squared. Be careful, grade 12s. What happens at this junction is you forget that the whole of the distance is squared. And you put the 2, but you don't square it. You'll get yourself into trouble. What I'm going to do now it's a math trick. I'm going to take the constants and put them in front. So this is 2G ME MA. 2 squared is 4 R squared. Hopefully someone is screaming at the TV and going, I recognize something. Of course you do. That is 5,000. It's the same as my original. Okay? I now have a comparison. So that means, and we go, well, 2 divided by 4 is a half, just for those of you that are struggling, times 5,000, 2,500 newtons. Okay? Do not forget the units. Okay? The way you lay this out, grade 12s, is extremely, extremely, extremely important, okay? I know it seems quite silly, and I've done lots of bits and pieces, but the layout tells your examiner that you understand what's going on. And the whole issue here is understanding the relationship between the mass and the radius, okay? It is a comparative question. It still looks like a lot of work, okay? Now, you absolutely, heaven forbid, could have substituted in the mass of the Earth, substituted in the mass of the satellite, and then substituted in the R. But if you had gotten this question wrong, they will not carry it down, grade 12s, okay? They will not take this, if you double it and put it down, so it wouldn't be this one, it would be R that we find the 7 times 10 to the 5. They will not carry it down, okay? Simply because it is not needed. And this was only worth 2 marks. If it's only worth 2 marks, that means there's got to be a simple way to do it. This is it, okay? Remember, directly proportional to the mass, inversely proportional to the square of the distance. It is the square that is going to get you, okay? So, grade 12s. What you need to be doing at this stage now, because now we've come to the end, learn your laws. We didn't touch on Newton's third law per se, because Newton's third law is explanation type questions. Reaction, action. Can't state it like that. Be careful. When object A acts on object B acts on object A with the same force, but in the opposite direction. Rockets going off into space. It's why we can walk. Okay? Very, 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 very important. Make sure you can state the laws. Make sure you know how to use the equations. And remember, we're dealing with vectors, which means we have to have size and direction. Okay, so on that note, grade 12s, this is where we are going to call it a day. Good luck. Make sure you study your grade 11 stuff, and we will see you again next time. Work to it, add a little bit of momentum maybe, a little bit of work, energy, and power, but it's all the same thing. Okay, so this is where we're going to start. So, in the diagram below, we have a 1 kilogram mass on a rough horizontal surface. As soon as you see the word rough, that means there is friction, okay? With friction being involved, that might be kinetic or static. We have to see what happens with the rest of the question. It's joined to a 2 kilogram mass by a light, inextensible string. What that means is that the string joining the 1 kilogram and the 2 kilogram can't stretch, first of all, and its mass can be ignored. Remember, mass does play a part in Newton's second law, but we're saying ignore it, okay? It is also running over a frictionless pulley. Now, that's important because if there's friction in the pulley, which is my circle over here, that will affect the way it moves. And they're not going to put friction in the pulley. That's just making it far too complicated. The coefficient of kinetic friction between the 1 kilogram and the kilogram mass on the surface is 0. You need to remember how to calculate friction, okay, using the fact that you are given the equation on your information sheet, which is great, okay, so make sure you know how to use it. You must know how to calculate resultant force, okay, and on that note, you need to be able to use the equations F net equals ma. Remember, that is from Newton's second law, and of course, F equals G m1 m2 over r squared, which is universal gravitation. Okay, and remember, with universal gravitation, big G is your constant. Okay, big G is your constant, will be given to you on your information sheet. You don't need to learn what that constant is. Okay, so don't stress about learning constants. All will be given to you. It's about being able to apply them. Okay, so let's dive straight into the first question that we have. And the first question that we have is taken from the grade 11 Department of Basic Education exemplar from 2013. Now, I'm sure some of you are going, but Tracy, why are we doing grade 11 work? Because this is grade 11 work, okay? And you are going to be asked it like you did in grade 11. Maybe add a little bit of grade 12, 0,13. So what they're telling you is that 1 kilogram mass experiences kinetic friction. It's going to be moving. And the coefficient, remember, which is mu k, is 0,13. So everything that I've done on my screen here, grade 12s, that is exactly what I would expect, or I suggest that you do when you get a question like this in your exam or any question. You all know, hopefully, about the concept of active listening. When you really listen to someone and in your head, you're not going, and you're thinking, okay, this is what I'm going to answer, this is what I'm going to say, but meanwhile, you're not actually hearing them, but you're actually listening, you're taking in what they're saying. This is what I like to call active reading, because sometimes it's just words on a page. So we read it, but actually nothing's going in. But by having a pen or a pencil or highlighter in your hand, underlining stuff, writing stuff down, things that you need to remember about the question, it really does make it easier for you later on, okay? So I've got a whole bunch of stuff written there. Let's go on to the questions and see what they say to us, okay? Also, I know, because I've said to you right from the start, that this is a Newton's second law question because I have two objects joined together, okay? That's a... Welcome grade 12s to today's lesson, and what we're going to be looking at today is we are going to do Newton's law of motion, okay? And this is grade 11 revision. I know I can hear the groaning because we all hated it in the grade 11, but unfortunately it is examinable, okay? So you've got to know it and revise it from last year. What you need to do is just go through, well, we're going to go through a checklist quickly of what you need to know from last year. That's important. Now, the first thing we need to look at is the fact that you need to be able to state Newton's first, second, and third law of motion, okay, as well as Newton's law of universal gravitation. Grade 12s, I know we don't like learning definitions. Learn them like a parrot, make a list of them somewhere, and just learn them. Get them from your textbooks, okay? Easy, 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 easy marks. You are going to get at least one of those four, okay? So make sure you know them. Very, very important. Secondly, make sure you know the difference between a free body diagram and a force diagram, okay? Very, very important. Why? Because if you get asked in your exam to draw a free body diagram and you draw a force diagram, you get naught, okay? They don't even look at what your labels are. They don't look if they go in the right direction. They don't care. It's wrong. If you draw a free body diagram when you're asked to draw a force diagram, you also get naught because you haven't obeyed the instruction, okay? You haven't answered the question. So make sure you know the difference, okay? Make sure you know how to label them, okay? Very, very, very important. Also, free body diagrams in particular are very useful when answering questions, even if you're not asked to draw one, because they help you understand the problem, okay? So they're very important. Thirdly, you must know the difference between kinetic and static friction. I know I can hear the groans because we hated that in grade 11, all right? But remember, there's a calculation based on it that involves the normal force and your coefficient of friction, okay? It's exactly what it sounds like. Kinetic means moving friction. Static is friction that is static, doesn't move. Remember, kinetic friction is the one that is constant, okay? Once we have an object moving, the friction won't change, where static friction will actually increase to a maximum before the object starts to move, all right? Very, very important. Also, you